Interest in the exoplanet Proxima b has been growing since its discovery in 2016. This is because Proxima b is located in the habitable zone of its star, which means that it could potentially support life. Recently, new telescopes have been trained on Proxima b in hopes of finding out more about the planet and its potential for habitability. So far, these new telescopes have uncovered some fascinating new details about Proxima b. For example, they have found that the planet is most likely an ocean world, with a large amount of water on its surface. So the question now is, could Proxima b harbor life? Alpha Centauri is a star system located 4.37 light-years, 1.34 parsecs from our solar system. It is the closest star system to our solar system and consists of 3 stars: Alpha Centauri A, Alpha Centauri b, and Proxima Centauri. Alpha Centauri A and B are both sun-like stars, while Proxima Centauri is a red dwarf star. The 3 stars are about the same age and are about 4.3 billion years old. All 3 stars are about the same distance from Earth. Alpha Centauri A is the star in the constellation of Centaurus. It is slightly more massive than the Sun and shines with yellow light about 1.5 times brighter. Alpha Centauri b is also a star in Centaurus. It is slightly less massive than our star and half as bright. It has an orange hue. The third component of the system, the red dwarf Proxima Centauri, is a small star. It has about 12% of the solar mass and a radius of 15% that of our Sun. Additionally, its surface temperature is low at just over 2,725 degrees Celsius, 4,940 degrees Fahrenheit. Proxima Centauri is the closest star to our Sun, lying just 4.24 light-years away. In approximately 27,000 years, Proxima Centauri will be 3 light-years away from us. Even though it is the closest star to us, the luminosity of the dim red dwarf is only 0.17% that of the Sun. Proxima Centauri often displays its stellar qualities by shining brightly in the sky. Scientists attribute the sudden burst of brightness to an increase in the star's magnetic activity. This also occurs on Alpha Centauri b, but not as frequently. Despite its close proximity to the other 2 stars, Proxima Centauri usually stays far away from them. Due to its eccentric orbit, every 555,000 years, Proxima Centauri approaches the Alpha Centauri pair at a distance of about 4,300 astronomical units. However, even at its closest approach, Proxima Centauri is still quite far from the other 2 stars. In a recent study, scientists have suggested that the Proxima Centauri star system may have been formed by the capture of the Proxima Centauri star by 2 Alpha Centauri stars. It is thought that this occurred millions of years ago by the gravitational pull of the 2 larger stars. The Proxima Centauri system is of great interest to astronomers, as it comprises a few planets in its orbit. Proxima b, one of these planets, was discovered in 2016 through the radial velocity method. This method is based on the principle that a star doesn't stay completely still when a planet orbits it. The star will actually shift slightly in a minor circle due to the gravitational pull of smaller planets. Researchers have long used spectrographs to study stars and their planets. By tracking a star's light spectrum, researchers can infer the presence of a planet orbiting the star. When a planet orbits a star, the star's light will appear to shift slightly in color. This shift is caused by the planet's gravity tugging on the star. If the shifts are regular and repeat at fixed intervals, then this is strong evidence of a planet orbiting the star. Astronomers have undertaken a careful study of the exoplanet and discovered that it appears to be comparable to Earth. Proxima b could have a mass of 1.3 times that of our planet, a radius of 1.1 Earths, and a similar density according to scientists. It is also possible that Proxima b is a rocky world just like ours. However, there are differences between Proxima b and Earth. For example, the location of the 2 planets in their solar systems. It is true that Proxima b is much closer to its parent star than Mercury is to the Sun. However, this does not mean that the planet is a fiery hell. The main difference between Proxima b and Mercury is that Proxima Centauri is a faint red dwarf. This means that the exoplanet only receives 60% of the energy of its star. Therefore, Proxima b is in the habitable zone of its star and could potentially support life. The main criteria for life to exist on the planet in the Goldilocks zone is that it is not too hot and not too cold for liquid water to exist on the surface. Proxima b meets this criterion, making it a potentially habitable planet. One of the most interesting things about Proxima b is that it is tidally locked to its star. This means that one side of the planet always faces the star, while the other side is in perpetual darkness. This creates a very interesting environment for any potential life on the planet. The side of the planet that faces the star is incredibly hot, while the side that is in darkness is incredibly cold. This would result in very different conditions on each side of the planet, and it is not known how any life forms could adapt to such extreme conditions. It is possible that Proxima b can have liquid water, although the conditions on the planet are far from ideal for life as we know it. Intense solar flares from the star can strip the planet of its atmosphere, making it difficult for any life forms to survive. However, we know that life is incredibly diverse and adaptable, so it's possible that some forms of life could exist even in these hostile conditions. At the start of its development, Earth was bombarded with intense ultraviolet rays, but it eventually became habitable for a variety of living organisms. The same could be true for Proxima b. Some astrobiologists believe that even intelligent aliens might be able to thrive on the planet, as they could build underground shelters to protect themselves from harmful radiation, or they could hide from the radiation by living deep in bodies of water. Now, certain life forms on Earth have the ability to fluoresce or emit light in response to ultraviolet light. This is an adaptation that helps them to survive in environments with high levels of UV radiation. Coral polyps, for example, produce fluorescent proteins that block excessive sunlight and protect the polyps from UV damage. It's possible that similar life forms exist on Proxima b. Next-generation telescopes might be able to detect the fluorescent signature in the atmosphere or on the surface of the exoplanet. If we do find evidence of fluorescence on Proxima b, it would be strong evidence for the existence of life on the exoplanet. If Proxima b doesn't have an atmosphere, the average temperature there would be around -40 degrees Celsius, -40 degrees Fahrenheit. However, if there is an atmosphere, the temperatures could potentially rise to 30 degrees Celsius, 86 degrees Fahrenheit, which is a temperature that can maintain liquid water on the surface. The issue is that the star nearby still sucks the planet's atmosphere into space. Nevertheless, scientists presume that Proxima b kept a part of its atmosphere. This is especially possible if it was able to form a thick gas shield around itself when it was younger. The loss of an atmosphere can be partially covered by volcanic eruptions or comet impacts. Scientists speculate that Proxima b might have a magnetic field potent enough to safeguard it from hazardous radiation. They look forward to testing their theories with the European Extremely Large Telescope. Even though the Proxima Centauri system is close to ours, it would take an extensive amount of time to get there. If we were to use a space shuttle in an attempt to reach the Alpha Centauri star system, it would take 165,000 years. However, scientists have formulated an astounding plan that will enable them to get a close look at the remote world without the need for telescopes. Under the Starshot program, a powerful ground-based laser will fire brief pulses of light at the sails, propelling the tiny spacecraft to speeds of up to 100 million miles per hour. At that speed, it would take the probes just 20 years to reach Alpha Centauri, which is 4.37 light-years away from Earth. Once they arrive, the probes will begin transmitting images and data back to Earth, giving us our first close-up look at another star system. The Starshot program is still in the early stages of development, but it has the potential to revolutionize our exploration of the universe. With this technology, we may finally be able to answer the question of whether or not we are alone in the cosmos. In 2019, researchers put forward the idea that Proxima c, another planet, could be orbiting Proxima Centauri. Its estimated mass is 7 times that of Earth. Its size would place it in the category of a super-Earth or small Neptune. Data collected by astronomers suggest that the planet's orbital period is longer than 5 Earth years, and that it is likely located on the edge of the planetary system. Given its distance from the star, Proxima c's temperature is probably less than -234 degrees Celsius. In recent years, scientists have discovered another potential planet in our solar system. This planet, named Proxima d, was detected by the Very Large Telescope and is considered one of the smallest exoplanets known to mankind. Proxima d has a radius of 0.8 Earths and is located about 4.3 million kilometers, 2.7 miles away from the red dwarf it orbits. It is closer than any other exoplanet known to man, and as a result, Proxima d completes an orbit around its star in just 5 days. Because Proxima d is so close to its star, it is not believed to be capable of sustaining life. However, some scientists believe that microorganisms could be hiding underground and hope to use a new generation of telescopes to figure this out. We have already received its first photographs from the highly reputable James Webb Telescope. Another telescope that is due to fly in 2023 is the Telescope for Orbit Locus, interferometric monitoring of our astronomical neighborhood. Its focus will be making observations of the closest stars in the Alpha Centauri system. What sort of discoveries are you hoping these telescopes will make?